Okay, so on page 35, this is a continuation of what we did on Friday right before break, and it's just to figure out whether two triangles are similar or not, and these are the three ways to do that. Side, 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 angle, or just angle, angle. And it doesn't mean, the S's don't mean that the sides are the same, it just means that they're in proportion. It means three sides are in proportion, the same proportion to each other. And it means two sets of sides are in the same proportion to each other. So it's not the same as it meant with congruence, that they're identical, it just means that they're in proportion. So if you looked at A here, there are two triangles. There's one that is 16 and 10, and then there's another triangle that's 22 and 14. So this might be side angle side, because if you notice they both share that angle in this corner, so it could be side angle side. But are these in proportion? 220 does not equal 224. So that's actually a no. Just because it looks like side angle side, you have to check to see if it's actually in proportion, and this one was not. If you try B, it's telling us that we have those angles that are the same, and you know that you have vertical angles, so we have an angle-angle situation. In question C, this looks like it might be a side angle side, so we have to see, does 7.5 over 4.5 equal 5 over 3? So you cross multiply to see if those are the same. 7.5 times 3 is 22.5, and 4.5 times 5 is 22.5. So those are in proportion, and there's a shared angle in the middle. So this is a yes because of side angle side. In D, this one you have to take apart to really understand it. So you could use patty paper, or watch me here. You have a 93 at the top, and I'm going to mark that angle with a little blue dot. So we have, try that again, that one. And then we have this triangle with a 93 and that same angle right there. So if I take this and turn it around, it's just a dilation and a reflection. There are two angles that are the same, the shared one and the 93. So it is, yes, angle, angle. This one only has one shot, and it could be side, side, side. We're just not sure yet. So it's a reflection, though. So 12 will go with 16, 15 will go with 20, and 6 will go with 8. So we have to test to see if these are all in the same proportion. Is 6 over 8 the same thing as 12 over 16? Is that the same thing as 15 over 20? They all reduce to 3/4. So since you can cross multiply any pair and you're going to get the same cross product, but if you notice that they all reduce to 3/4, they all have the same scale factor. So this is a yes by way of side, side, side. F, I want to put D and F on the screen at the same time because they're identical types of problems. That's a 90 with that corner. So if I was to draw this again, you would have that triangle. There's a 90, that same corner. It's a 90 at the top and the shared angle. So that's just like question D. There's a shared angle and a double 93. So why don't you take it from that line down and see if you can figure out G through Q using either angle, angle, side angle side, or side side side, but you have to check to see if they are in fact in proportion. So pause the video and do that section. I'm not going to put the answers up yet because I don't want you just to copy what the answers are down on your paper. I want you to see if you can get these on your own. And then I'm going to have you pause it, and we'll start from page 36 with actual proofs. So statement, reason, proofs for similarity, not congruence. They're pretty similar, no pun intended, but they'll have a given, right? And you always put the given on the first line, and your prove will always be the last line. If you want to fill that in now, it doesn't have a good flow when you do that, but it'll remind you that that's the last line, which sometimes we forget. And this is either going to be side, 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 or angle, angle, or side, angle, side. We're just not sure yet. So the given one is already marked on the picture, but there's something else you know. You know vertical angles. You want to call it 1 and 2 like we used to? Go ahead. Angle 1 is congruent to angle 2 because vertical angles are always congruent. And we now have angle, angle is our reason for those two triangles being congruent. The next one. Notice it looks kind of confusing at first, but this line is extra. So I know you don't have a bottle of whiteout at your desk, but I'm going to get rid of this line right here, because then all you see is this triangle with a right angle that has an angle A, right? And then you have this triangle that has a right angle and angle A. So they share angle A and they both have a 90. So it says that it says that they are right angles. So I'm going to go ahead and say, well, if they're right angles, then they're congruent because all right angles are congruent. And then I'm going to say that angle A is congruent to angle A because they share this corner down here. They both share angle A. And when an angle is on top of itself or a side is on top of itself, remember we call that the reflexive property. So we are ready to go. We have our angle and our other set of angles. So I can now say that triangle ADC is similar to triangle AEB, again because of the angle-angle theorem. This one has parallel lines given. So the arrows are on there, probably easier to see on your paper. So if these two lines are parallel, and I have a transversal coming through, that means I have alternate interior angles at S and T, and that also means I have another transversal this way. So angles S and G are also alternate interior. Or you could have just done one set of alternate interior and gone after the vertical in the middle. That's up to you, because you only need the two sets of angles. But I chose the two alternate interior sets. So because they told me it was parallel in the first line, I'm now going to say angle S is congruent to angle G. Actually, I'm going to write that a little bit smaller because I'm going to put the other one on the same line. Angle R is congruent to angle T. Both of those are true because alternate interior angles are congruent. So I'm ready to say that the two triangles are congruent, but notice this time it didn't ask me to prove that. This is sort of like the CP-CTC idea. It's not CP-CTC because C stands for congruent, but it's that idea that you go one more step past the triangles being similar. So first I'm going to say that triangle SQR is similar to triangle GQT because of the angle-angle theorem. And then I'm going to say what it asked me to say. QR over QT is equal to the proportion QS over QG. And the reason for that is similar triangles have proportional sides. That's sort of like the CPC-TC version of similar triangles. If it asks you to prove something different, you just have to have a reason for it. Same idea here. There's something we're going to have to do after proving the triangle is congruent, but we'll get there. Right now it marks these two to be congruent to each other. And I'm going to redraw them. If you had patty paper, this would be the way to go. G, F, H is the first triangle. And they share, they share angle H. So I'm going to mark that. And then I'm going to trace the little triangle. And it has that shared angle. And again, angle H. I'll label the vertices too. So just like those two problems that we did on the other page, when I turn it upside down, it's the reflection and the dilation. So I can now say that angle H is congruent to angle H. They shared angle H, and that's called the reflexive property. And now I can say the triangles are congruent because I have AA already. I have an angle there, and I have an angle there. So triangle GFH, I'll call it. So if I call that one GFH, I have to call the other one IJH. And they are similar because of angle, angle. Now why are there two lines left? Because first, let's go back to this statement. That looks like it's already been cross-multiplied. So think for a minute. If I had HI, see how it says HI times HF? Well, that must have come from a cross-multiplication like that, which means HG and HJ right here must have come from this direction. So this actually goes here for the same reason we had here, in that similar triangles have proportional sides. And then we write exactly what it said here. HF, actually it's HI times HF is equal to HG times HJ, because cross products are equal. Now, obviously those are new ideas here, but now you understand that you can go past just saying that they're similar and prove the statement that they ask you to prove. So stay with me here. I'm just going to talk and you're going to write. So notice I have the parallel lines drawn in and the transversal. So that means that those two angles are the same. So I'm going to say angle B is congruent to angle E because corresponding angles are congruent. Then I'm going to say that angle C and angle F are on this transversal. So angle C is congruent to angle F, again because corresponding angles are congruent. And I have two pairs of angles congruent, and all it wants me to do is prove that triangle ABC is similar to triangle AEF because of the angle-angle theorem. So skip over the last one, go to page 38, and I want you to try for your assignment B, E, and F. B, E, and F on page 38.